how do I know this thing is not gonna email my ex-girlfriend signing up for my new product?
Even if an individual browser action is 99% accurate, if that trajectory is 100 steps, then that agent has over 60% chance of failing, just because that's just how the math works. The biggest alpha in AI right now is actually like upskilling yourself and making yourself smarter. It's really easy to vibe code yourself into oblivion. I released this article on Twitter called "What if fully autonomous is the wrong goal?"
For a true agentic economy, agents need to be able to browse the internet autonomously on their own. And that's exactly why we brought on Derek Meegan, who is a lead engineer at Browserbase, to talk about what it takes to make agents truly autonomous across the internet and the technology that they're working on to allow agents to browse the internet with ease. So Derek, can you tell us about what a browser agent is and how it's different from like a Playwright script, and then also cue into Browserbase itself?
For sure. So first of all, if you want to start with what is an agent, right? And so we all know what a large language model is, or maybe hopefully everyone that's listening to this knows what a large language model is. But an agent is essentially a large language model on a loop, right? That is sort of continuously operating to achieve some sort of objective. And there's sort of varying degrees of autonomy for an agent. You may have an agent that checks back with you on every single turn. You may have an agent that's set up for long horizon tasks, or you may have an agent that is calling tools that individually require human in the loop for approval. And so a browser agent is just an agent that operates on a browser, just like a human does. It opens up a Chrome browser and clicks buttons, fills in forms, completes tasks on the web, primarily on behalf of people. And so the way Browserbase slots into this whole browser agent story of, agents completing work or taking actions on behalf of people over the web is we provide the infrastructure that your agent needs to operate on in order to interact with the web, right? So whether that's search, whether that's fetching content from a page, or whether that's launching a real browser that your agent can use to interact with websites.
And this is a little bit different from other companies like Exa or like Firecrawl, where Exa allows you to basically like search and retrieve information, and Firecrawl will like take the entire web page. They're like different approaches. And you guys specifically basically are crawling on the browser. Is that a good like articulation of exactly what you guys are doing?
Approximately, I would say we're a superset of Exa, Firecrawl, and then really the foundational player in the direct browser infrastructure space. And we're not doing crawling on behalf of our customers, but instead exposing a full platform of tools for them to operate agentically on the web. And to answer one of your original questions as well around how browser agents differ from Playwright, historically, Playwright is actually a testing framework. Same thing with Puppeteer, and many of these other like foundational browser automation libraries. And they simply have been repurposed before AI for maybe some nefarious reasons. And now in the age of AI as the, direct hands for agents to click and type and operate on the web. And so browser agents are very attractive because of, number one, there's this perception that there's a low necessity for configurability, right? Like I can basically just shout some directive at an agent and then it'll go off on the web and do that thing for me. And that feels great, right? And a second perspective, LLMs also kind of bring sort of ambiguous decision-making into code, right? And that's really difficult to model in strict like if or else statements, right? And so when companies or people have deployed Playwright scripts in the past to automate actions on the web, they've been highly susceptible to breaking through, very simple website changes. And so with that nature of LLMs being able to make ambiguous decisions, you unlock the capability to heal actions at the step or even the trajectory level in more complex cases.
Got it. And traditionally, people were kind of like mapping the website, and then essentially, if like a button moved like an inch over, then
Right.
the script would fail.
Yeah, and like I think that's like conflating sort of the nature of a selector, right? And so, what is a selector? It's like basically some ID or some signifier, basically some string that maps to one or more elements on the page. in traditional Playwright or Puppeteer scripts or other browser automation libraries, we're treating those selectors as code. That's not actually code. It's really data. And that data can be used in different ways across different scripts, right? You may click one button in another script and click that same button in a different one. And what generative AI has allowed us to do in the browser agent space is kind of bubble up some layers of abstraction. And instead of operating on these selectors, which are really sort of implementation detail to completing the goal, right? We can instead, in the most extreme case, right, like in fully agentic browser automation libraries. So, Stagehand Agent or Browser Use is another example of this, or there are several other browser agent libraries. You give that top level task, and that agent loop and that agent library kind of takes care of the rest. Whereas, obviously that juxtaposes to Playwright, but also Browserbase maintains a browser automation library called Stagehand, which allows you to define individual actions in natural language, right? So you may still be attached to like one particular trajectory, right? Like this flow, you need to fill in the first name box, you need to fill in the second name box, you fill in the address, and then you click submit. But you don't want to attach to the particular selectors that underlie these elements on the page. So Stagehand allows you to say like, hey, for this one action, like fill in this box. Then for this next action, fill in this box. And those two sort of directions are to the model are independent of each other.
Got it. Okay, so we have the agent, which we described, and then we have this ability to interact with the browser. And just so we have this full picture before we kind of get into the weeds, why would someone want to essentially have their agent look onto the browser?
I think there's like, two, or maybe I'll like differentiate between three like types of browser trajectories in the context of this, right? Number one, you have this notion of like just-in-time automation, right? Where, you're doing regular, and there are like many consumer AI browsers that are seeking to converge on this space, right? Think about like Perplexity Comet or Dia. They're basically, these agents are sitting alongside the human operator as the human completes many varying types of tasks. And the agent or the human may say like, hey, agent, go do this thing while I do this other thing. And there's no notion of like repeatability or scalability in those particular automations. Then you have sort of like a third type of trajectory, which is like clicking and typing is for some like higher purpose, right? So you may have like a UI testing agent, or you may have a competitive analysis agent, or a deep research agent. And they are clicking and typing, but not for the purpose of clicking and typing, but rather to, incrementally gather information or quantitatively like assess the nature of like, for UI testing, like, okay, let me click on this button and then let me measure the time it took to like load the page or be redirected to a new page. And then lastly, and these are like the highest volume use cases, are sort of transactional browser trajectories. And we see this a lot actually more with enterprise customers where, traditionally they've used these hard-coded scripts and they have to spend a lot of human capital to maintain them. But instead, you can shift those human capital costs towards model costs, right? And given a sufficiently constrained problem space, sufficiently instrumented observability, you can create a browser agent that is reliable, is cheap, and is resilient to sort of step or trajectory level changes on that particular website. And so, the goal there is to sort of have the best of both worlds, retain some elements of determinism, but get those assurances of variability without having to slot humans in between each individual.
Got it. So where do these workflows traditionally break down? And this will kind of lead us into the problem statement now that we have like a clean slate to work with. Where traditionally have people had issues, and basically what have they been not able to do on top of that because of it?
Yeah. I mean, I would say traditionally like browser automation is hard, right? Like it's just plain hard. There's a lot. It's very dynamic. I wouldn't necessarily say like Playwright, Puppeteer, or other browser automation libraries, like their interfaces are particularly intuitive for people. And then there's a lot of nuances with Chromium, with anti-bots, with the identity, quote unquote, of the particular automation or agent that's taking actions. So, there's both this like functional difficulty in standing up these automations. There's sort of these unknown unknowns that make it difficult to make predictable, reliable solutions for automating browsers. And then, there's just conceptual hurdles to overcome in order to sort of bring that like know-how and art into an organization to where you can build these automations at scale. And then, I would say now as we're introducing browser agents, of course you solve one problem, but you create new ones. Cost is definitely one of those. You can get very good computer use results from some frontier models, but it's simply not economically feasible to deploy Opus like across 1 million trajectories like a month, right? So, okay, this is a very high value, flow and high volume, right? Or, maybe it has some value, right? The flow, but what is that value relative to that cost, both from a COGS perspective, then from an implementation and maintenance perspective? And that's where things start getting a little complicated.
Okay, so now that you do have these solutions to essentially browse or depending on your workflow, interact with a browser using an agent, you're saying now that it starts to multiply on different types of problems that occur there. Where do you see kind of these big or like the most ambitious problem space now that you guys are doing the work in, as of now?
Yeah. So you think like, oh, okay, you basically have these LLMs that can go and take variable actions on the web. Like you're probably building like these crazy like digital online workers that are doing all of these dynamic things. And I think I can see why people would think that, right? I can see why people would think that. But in reality, you're expanding the realm of what traditional browser automation was, incapable of doing. But you're building on the type of tasks that traditional automation would automate, right? And so, there's a lot of, let's say, like receipt retrieval is like a big use case, right? And this supports like, different finance workflows, right? Like we have a customer, Ramp. Ramp is one of our great customers. Nice. And we've partnered with them on helping create agentic receipt retrieval that's resilient to sort of traditional automation detection, traditional like changes to page structures, right? So these are all problems that have already existed, but these new solutions or these new tools are offering new classes of solutions that weren't available before, right? And so we're really focusing on these like high volume transactional workflows because they're clearly measurable and it's easy to attach a value to a trajectory. Of course, we also service these these UI testing workflows or these deep research workflows. Deep research in particular is definitely interesting, especially now that we have this combination of search, fetch, which is sort of like a curl equivalent. But of course we add like extract or markdown transformation on top of it. And then the browser, these three together is actually plus an LLM. There's your recipe for a deep research agent. And you can create a verticalized deep research agent for any industry or your particular company. And we found for us that it's super valuable, especially for our go-to-market, to automatically have a deep research agent kicked off when a lead is created in our CRM, right? And we can enrich information about that lead. We can compare that lead to other customers that we have in our customer base and say, hey, what solutions might be relevant to them? And that informs our go-to-market org and our sales engineers when they go and speak to the customers. So I think, there's an opportunity, of course, for like information synthesis, information retrieval. Of course, this like just-in-time browsing sort of use case creates a lot of different dynamic use cases. Although we focus on them less from an enterprise. Like inherently, these are not like scaled workflows that are repeatable, and it's easy to tie like some like static value, right? Like if I know, if I'm Ramp, if we retrieve these receipts automatically for our customers, that represents like some quantifiable value. And then they can pin that quantifiable value against like the cost of upkeep, the COGS, et cetera, right? Or in the initial development costs of the project, et cetera. And I think these transactional browser automations do present like a very interesting unit economics problem, right? Because, on one hand, each step that you take with the LLM, and this is not just with browser agents, this is with, any agent, if there's some overlying, task for the entire trajectory, each time you take a step, there's this marginal increase in likelihood of failure, right? So you're accumulating risk, right? Something may go wrong. The agent may go off the desired trajectory. There could be some infrastructure failure. The agent could hallucinate, right? There's basically an innumerable amount of ways in which the agent could go wrong, right? So you're constantly accumulating risk. But with these transactional flows, right? Like if I'm retrieving a receipt, there's no value to me if I get 50% of the way there to retrieving the receipt or 80% of the way there, right? So value realization is terminal, but risk accumulation is continuous. And same thing with cost accumulation, right? So you're accumulating costs and you're accumulating risk, but you aren't realizing the value until you get right at the very end. And that's like a particularly brutal like combination. It makes it really tough, right? Because like I mentioned in the beginning, the perception is I like throw some directive and then that directive gets completed. But of course there's context, sort of breakdown between, what I say and what I'm thinking, right? There's unknowns about the website that the agent may be embarking on. And so when we see, customers that come to us, and they say like, hey, we want to deploy these browser agents at scale, we need to sort of ground them in what real applied AI actually looks like. And this is not just like a magic box, right? As much as we would like it, as much as we would like it to be, right? This is really like fundamentally an observability problem. Like you need to understand what the agent is doing, right? Once you've understood that, right? What are the key success criteria for a particular trajectory? So, and ideally this is deterministic, and the agent can invoke this like midway through the trajectory, right? So let's imagine the case of like a bill payment, right? So I give the agent, here's this website, here's like a credit card, right? Here's some, billing information. Go on this website, fill out the form, pay the bill, right? Very easy. And this is very easy to demo. And I've personally demoed this before, right? Like click, type, boom, submit, boom, where do you sign, right? But the problem when you go and scale this is even if an individual browser action is percent accurate, right? Like let's say I gave you a browser agent. I'm like, here's a browser agent. Every step that you ask it to do, 99% of the time it'll get it right. If that trajectory is 100 steps, then that agent has an over 60% chance of failing. Just because that's just how the math works, right? When you go 99 to, the power of 100. Mm-hmm. So you really need to ground yourself. What is an agent, right? This is not a person. This is not, some magic thing that will solve all of my problems. An agent is an LLM on a while loop, and an LLM does next token prediction. And what I'm implying by saying an LLM does next token prediction is that you can think of the output of an LLM as a probability distribution. And somewhere in that probability distribution is the outcome that we want on each turn. So how can, as my agent goes through the trajectory, can I limit its output distribution to the portion of the possible distribution that I want? And context engineering is like one way. I think another way is that, if you know that on each step that you accumulate some marginal risk, how can you eliminate steps? And this is where we've seen some interesting solutions with sort of, have you heard of Karpathy's auto research?
Yeah.
Yeah. And so, the basic premise is you give the agent like some quantifiable goal, right? And then you set it off on a loop to do everything under the sun, like diverge across all types of strategies until it can achieve like that. Or the same thing with like codecs like /goal, very similar. We've been experimenting internally, and we've also like shared some skills like publicly for auto browse, where we release an agent with this clear directive to run iteratively on a website and find that critical path through the website to complete that automation. The less steps you have, the less costs and risks that you accumulate, the faster you can get to that terminal value realization. So it's like a super interesting set of forces that interact with each other. And there's a lot of education that we need to do, like with our customers. Not only, what does this observability look like? How do you define the correct success criteria? But also, hey, how do we work with them to really understand the domain of their problem space, the possible failure modes that their agent may encounter, and like planning for as many as possible for them, and then curating an environment for their agents in which, when you think about the possible output distribution of any one action, it's as much as possible constrained to actions that we want and not the ones that we don't.
Got it. Wow. Yeah. Thanks for diving into the nuance there. I want to put a pin on the ramp and the ramp use case and come back to that in a second. But to follow up on this statistical problem, right? Because when someone talks about agents, they're typically thinking like, okay, I'm going to set this up and it's going to do everything and come back and I'm going to take a shower and it's going to be ready, right? And what you're saying is there's actually a statistical distribution problem baked into the success of agents, which is kind of like what people do in trading. It's almost very similar to trading and like probability of taking a certain amount of trades. So my question is, if each run for your agent to go retrieve a receipt cost $1 and $1 of compute or like resources, right? Because you can't just price on the completion necessarily, but the resources do cost money. How do you actually phrase this to the customer? And is it actually based on like completion, or do you say, hey, it's going to probably take this many runs and it's probably going to cost this amount in the aggregate to successfully do this task? Like, are you guys going that granularly into the customer, or maybe you can just explain, how are you looking at that problem?
Yeah, I mean, I think by the time, customers have arrived at, we need to implement a browser agent to do this, they've determined that it's a pretty high value flow, right? And where, what are the unique affordances that a browser agent gives you is the ability to navigate ambiguity, right? And so we are approached with use cases that have ambiguity inherently built in. And our goal is to sort of put a box around that ambiguity and make it very easy for the agent to reason about that ambiguity and then implement as much determinism as possible around it. So a very rudimentary example, and this kind of goes in line with like, the best step in a browser trajectory is no step, right? Is in your prompt, don't even give a website for your agent to navigate to. Like, okay, if I have a browser agent, why don't I just navigate to the website first and then tell the agent, go and do this thing, right? And this is something like, this is like the easiest mistake to mess up, right? Because you're just like, oh, I'll set up this website, or this agent, all I need to do, drop the website in the prompt, go and do this thing, blah, 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 and then send it off. And then it's taking this action for no reason, right? And so you're just like thinking about those numbers and thinking about, you especially have to think about these, like, the statistical behavior of these trajectories when you're thinking about, okay, I'm working with an enterprise customer and their scale is in the magnitude of thousands of trajectories, tens of thousands of trajectories, and things start to normalize. The weird things start to come out, right? And this is a little bit different of a problem than, our friends at Anthropic who are adding computer use to Claude Cowork. They just need to, maximize the performance on their evals. Maybe there's a key number of sites that they know their customers go to, and they can sort of formulate, maybe special skills or tooling to, complement their Cowork agent, like operating on those sites. But yeah, so when we work with our customers, like, by the time they get to us, they understand that there's a level of ambiguity. Today, they now understand that tokens aren't necessarily free, right? And the first order of business is, hey, like, is this capability even there, right? Like, can we, see some level of reliability, right? In that equation, right, what is the cost associated with one trajectory? And then how many trajectories are necessary to complete a unit of work, right? And so there's a difference between like the success per trajectory and then the success per unit of work with some capped number of retries, right? And so for example, you could have 50 trajectories that span across 5 units of work, and each unit of work only had 1 success on the 10th retry, right? So that's 45 failures, 5 successes, right? You would add that up to like a 10% success rate, right? But hold on, right? If you permit 10 retries and on the 10th retry for each one, you got a success, then in reality, on a per unit of work basis, that's 100% successful. So if it takes 10 retries and the value of that work, the unit of work being completed is higher than the COGS of 10 trajectories, then you may tolerate a per trajectory success rate of 10% because your per run success rate is 100%, right? So there's like a little bit of like some math and like framing there. And of course, that doesn't always look like, 10 retries, right? Usually we recommend maybe 3 to 5. And we encourage our customers to target something around like 75 to 80% success rate on their trajectories. And that's extremely doable. One thing, that we've increasingly seen from our customers as well is this desire to maintain one harness, right? I have, again, we're talking about operating in ambiguity, right? So we work with another customer for bill pay, right? They want to pay bills agentically on the web. Well, right now they have really brittle RPA. They have people with boots on the ground that are upkeeping and monitoring this RPA.
What's the RPA?
Remote or robotic process automation. There's like a very arcane term from like 1848 or whatever to describe like automating browsers, right? Or automating stuff on a computer, right? It was like kind of like really bringing like Playwright automation or other computer automation to a business context. RPA, brittle deterministic automation. And then they have this long tail of websites that they pay bill on, they need to pay bills on, but because they're so low volume, they just have humans going in, taking the information, going in, clicking and paying the bill, right? To do that last mile. And so their desire is like, hey, we have technical debt. We have all these human operators, like basically clicking through websites. Like, how can we use agents to get the best of both worlds, have repeatability with a high level of success for our highest volume websites, and then be able to capitalize on using agents for these long tail of websites that we do not want to like maintain RPA for. And quickly it became an issue with trying to funnel all of the unique differences between each website into one harness, right? Like one website has like a certain flow where maybe you have to click a checkbox, and another one like you don't, right? So then it's like, how do you differentiate these? And what actually came about is equivalent to what we would call today like a skill, right? You kind of write in natural language like, hey, here's how to traverse through the critical path, right? There may be like some changes possibly, but this is likely the critical path that you need to go through. And then that brings us back to like what I was talking about earlier, in that you can think about the output of an LLM as a distribution and it's trying to predict the next token. And so if I tell the LLM like, hey, when you go to this website, like you're going to see this thing on the page, you need to just click this button at the bottom. If you have one agent that's told that and given the website versus one agent that's just told what the overall objective is and then given the website, the first agent, its output distribution is skewed towards that outcome of like, hey, you're going to need to click this exact button in order to propagate to the website. And because that's represented in natural language, that looks more like a standard operating procedure that non-technical operators can approach and say, hey, Browserbase offers video recordings of exactly what happened on the browser and what your agent was doing. I saw the agent go and do this thing. I don't need to write code, redeploy, like test, right? I just need to update the agent's standard operating procedures and continue to observe. And so that's like the fundamental difference that we see when customers want to deploy one harness across many different websites is there still needs to be some level of customization on a per site basis, but maintaining that in standard operating procedures is much more preferable than maintaining like custom code or RPA solutions.
Got it. Wow. So on the harness piece, and just for the audience, the harness is like the engine, or excuse me, the model is like the engine, and the harness is like the car built around it that can, has bigger tires or smaller tires to do specific things. Derek, for you, these harnesses, are they custom harnesses, or are they using like Claude Code or Cowork or some type of like generalized harness for like these use cases?
Yeah, I mean, we offer our own browser agent. Stagehand, well, Browserbase is the main maintainer of Stagehand, an open source browser AI automation library. Within Stagehand, there is a browser agent framework built on top of AI SDK. As models like improve, I think the exact shape of the harness matters like a little bit less and less, right? Because the model is doing most of the work. But I really think about it like there's four things, right? There's the model, there's what's around the model, there's the human, and there's what's around the human, right? And a lot of times we're thinking about like agentic work completion as if like humans are not part of the equation, right? We're just like, oh yeah, like there's all this work to be done, and then all these agents are going to do it, and like, but wait, like where is the human in that story? Because the humans are the one that's asking for the work to be completed. The humans are the one that need to verify that that work is going to be completed, right? And so I think that the discussions around harnesses often omit one of the most important things that the harness should be serving, or maybe what's exposed to the human about the model's harness. So you can think about like the human harness, the interface, right? Or the different ways that the human can sort of peer behind the curtain to what is the agent doing, how many agents are running at once, what does the cost look like, how can I steer an agent, what does human in the loop look like, what are the different failure modes, etc. So when it comes to harness, I think this is something that's like constantly evolving. I think we've even seen a fresh, perspective on this from browser use in their browser harness product. Or, it's not really a product, but more like a framework, where it's essentially like completely bare bones. And then you ask the agent to build its tools on the fly. I think that's like very interesting for these like just-in-time like browser agent use cases, but also like completely unsafe from a security standpoint, right? It's like, I don't necessarily know, like with all of these supply chain like attacks, if I want my agent NPM installing anything. Like, I don't even want to NPM install, right? So then I get a little bit scared when like the agent can, arbitrary tools or modify its harness, because if that agent is holding anything that's like very, sensitive, right?
Yeah.
API keys, credit card, right? These type of things. I do not want the agent modifying its harness, and as, that all being said, as much as, we give Claude Code API keys, I know you've given Claude Code an API key. I've never even watched you code, but I know you did it, so, yeah. So, that's all to say there's a lot of competing opinions around harnesses. I mean, I think it fundamentally comes down to, protecting context. Whoever can protect the model context the most, give it exactly what it needs, and, in doing so, shape the output distribution to be higher quality. Mm-hmm. That's really what matters out of a harness. But I think broadly, the industry will converge on a right way to do it, because really, like, LLMs is it's one thing, right? Like there's not a mechanical difference between how inference works from XAI versus inference works from Anthropic, right? So there is a world where you can create the best harness that protects the context of the model most aggressively and like permits the most like dynamic tool calling, like etc. But I think right now the name of the game is like balancing those dimensions between performance, cost, and maintainability.
Yeah, the way I like to look at it is almost like driving on the road, and there's like these huge potholes that you have to like go into, and like the nuance of like actually using these automations and agents like shows itself in the potholes. And we're just not at a place where like the customer can just fly across the road. they kind of have to meet you at some point. Like you can build some scaffolding or like, fill the hole a little bit or a lot, right? But still it's not completely filled. And like working with the customer or even like as individuals working with the tools to kind of see where the limitations are is like the name of the game right now. And even if you can bridge like 50% of the gap, it's not like full blown, just, you click it and it just does everything. There is like a lot of damage and clearly, billions of dollars of value that is moving around because of like the gap is semi-filled. So yeah, I like how you're
Yeah,
kind
for
of
sure.
showing the reality and the nuance between what are the capabilities and like what the customer's expectation is and what's available and kind of meeting them in the middle.
Yeah, and I think there's like there's a like a fallacious binary that's proposed, which is that you can either have a human or you can either have an agent do it. And I think that's like is very simplistic thinking, right? Like in reality, we ought to be thinking about how humans and agents can interface together as like something cohesive to complete work, right? And that is so much more powerful because there are many ways in which agents and humans are complementary, right? Like they can sort of cover for weaknesses in the other, right? So for example, I as a human need to sleep, eat, drink water. I require healthcare, shelter, etc. These are all things that LLMs don't. Well, maybe they use water, right? But an LLM, conversely, hallucinates. Is you fundamentally cannot hold an LLM accountable, right? I think like actually like IBM sort of originated this is like you cannot hold a computer accountable, therefore like do not let computers make management decisions, right? So you can think about instead of trying to like live in this world where it's like, oh, well, only humans can do it or only an AI can do it. It's like, well, how can we set up systems together, right? With those four things, the model, what's around the model, the human, and what's around the human. So we can maximize certain key business goals around work completion. Are we going to do it faster? Are we going to do more of it? Or are we going to do it cheaper? Or are we going to create a better experience for customers? And so I think there's like a lot of opportunity there. It's a little bit more difficult, in the browser agent space to think about that because more often than not, you sort of like bisect responsibility between human and agent because, co-piloting an agent on a browser, it's like you might as well just click through it yourself, like and that's how like a browser agent differs from like a coding agent. Each individual action on its own is like very low value. Like it's a like a click is low value, a type is low value. Where like on one turn in Claude Code, I could, the agent could output code and like code is very valuable. So I think, in the browser agent space, there's more of this binary between like what humans will do and what we want to set up agents to do. But I think if you look beyond that, right, or if you look at tools where using the browser, or if you look at agent like an agent where using the browser is only one tool and only one use case out of a broader set of use cases, there's some interesting dynamics that I think are emerging in like human computer interaction.
Mhm. That's interesting. Yeah, because I've come across times where I instructed like my browser agent to basically do something, and I'm like waiting for it to complete. And I'm like, I could have probably just done that faster,
Exactly.
because like the cost or like the time and effort of that specific action was just more valuable for me to do. It just cut the time I was waiting or kind of the focus, right? It's almost like I have to actually calculate the focus that I'm either gonna lose or like the context switching. And that kind of reminds me of what you're saying, but more on like an enterprise level of like this determinism versus agents. And for that piece, like can you kind of split between what constitutes something to be deterministic versus what constitutes something determinism as in like rules based, right? Where it's like, follow one, two, three, and these are the rules. And whereas like that differs from agent or agentic reasoning.
Yeah. I mean, I would say it's like one thing needs to be sort of a moving target, right? So you could have very deterministic rules, but those rules are applied in different environments, right? So that's the example of like the bill pay customer, right? Like they have very specific rules for what they want their agent to do, right? Fill in this information and click this button, right? But those rules are applied in different places, right? Or you have one environment, but you're applying different rules, right? You have one harness, and that harness is satisfying different use cases, right? Basically, one component that's critical to the work being completed on a particular trajectory needs to be like not static in an unpredictable way, and that's where these agents really shine, because they just unlock, like you just like functionally like weren't able to do this before. Like, if you were to task like this bill pay customer and say like create one Playwright script that can handle, like can even theoretically pay a bill to any degree of success across thousands of websites, if you were to task them with that, like that's just like functionally impossible, right? And then today though, that is less than 150 lines of code and deployed in Browserbase's cloud. So that's like super valuable, right? Like they could come to us, they can host their code with us, they can use our browser automation framework, we can give them best practices around that, they can use our browsers, and all of a sudden, like this problem that's requiring people to maintain, that is constantly breaking, is completely a headache, it can be augmented agentically, right? Is it something that like you set and forget and you never think about it forever? No, right? But is it better than the previous state? Yes. And is this something that will certainly benefit from the inevitable increase in model intelligence and decrease in per unit token cost? Yes, right? So that's also a great thing, because you can kind of make this investment today and you have some level of assurance that like things are just going to get better.
Yeah, that the point that you're like you touched that quite a bit actually, is like if you kind of lower your expectation for the maintenance almost of these things, and kind of like kind of conceptually like being open to monitoring and improving, like you enter a different phase of like what is possible with these agents, because there's almost like a cognitive limitation where if you just think they're one shot, then you're not going to get the value. But if you don't think they're one shot and you're like working on these things, there's just so much upside, and you can kind of really like perceive the capability. And I think just in general, there's not a lot of people who truly perceive and can feel like the model capabilities by like deploying these very specific workflows or stuff that actually matters, where there's like stakes, right?
Yeah, I think, it's sci-fi versus reality, like point blank and simple. These are not like magical thinking machines.
Yeah.
This is like, this is calculus. This is linear algebra. This is matrix multiplication, right? These matrix multipliers are cooking us on coding, dude. These things are better at coding than me, right? So it's powerful matrix multiplication, but it's matrix multiplication, right? And that's why it's like, I think it's this framing, and then like finally I think I'm getting a bit better at articulating it, because I think I've internalized it from like just repeatedly working with AI, right? Or kind of working with our sales team to deploy this with our customers, and really coming to understand actually from the other side of it, right? Not from the academic side, to say like, oh, like this is a framing that makes sense, right? It is next token prediction. It is next token prediction. What is the current token? What is most likely the next token, right? What came before GPT-3? You would say like, today I am tired because last night I did not. And then you train the model to say sleep, right? And then you train to say a few multiple words, and then sentences, and then paragraphs. And then you scale that, and then you have something that sounds like intelligence, right? And I think that's another important point, right? Like people will like look at an AI image and they know that it's fake, right? Like they're like, oh, that's a fake image. Like that scene never happened in real life, and like that's fake, right? But then they look at the output of AI and they say, those are real thoughts. And like there's like a breakdown between that, right? Like actually what you're looking at is probabilistically correct looking thoughts, right? And like, could those probabilistically correct looking thoughts be applicable to solving a problem that you're trying to solve? Yes, right? But also very much no. And this is like, I think sort of the crux of like AI psychosis, right? And like people convince themselves, especially with the assistant persona, right? And I haven't quite decided if that is the model or what's outside the model, right? But the assistant persona that like is prompted and like RLHF'd into like the ChatGPT web app or the Claude, like the Claude persona is actually very good, but like the Claude persona, etc. Like, these type of personas are very agreeable. They're post-trained to have a certain behavior. There are negative externalities to that post-training. And I think that's very like consequential for people like basically trying to ideate with LLMs, thinking that what an LLM is going to say back is essentially equivalent to a real thought, when in reality, it's the result of matrix. Like this is matrix multiplication. This is matrix multiplication. I can't say that like enough times, right? Because people like type into it and they get out magic stuff and then they think it's magic. It's not.
Yeah, that is such a great framing, because it does feel like thinking. And I think your point too, it could be it's probabilistically correct. It's probabilistically the next idea per se, or could be something that's real. And the like the cognitive security education of people like saying this, there's none, right? Like the model companies literally do not discuss this. And I don't even hear people online kind of talk about how to perceive these things, like mentally, the mental model in which to engage, because the mental model in to engage changes your expectation, and actually does in a good way, right? Because then you can know what it can and can't do and its limitations. You get better performance. So yeah, I really appreciate that. I like your way that you frame that.
Yeah, I just don't think we understand it like that well, right? Like, not just like people don't know what next token prediction is conceptually. Like the frontier labs don't quite understand the phenomena of large language models. Like we don't even understand the best way to like think about this. Like ChatGPT came out 5 years ago. Coming up on 5 years later this year, right? In October. We still don't know the best way, right? Like we're still like, MCP, CLI, like custom tool, like blah, 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 all these different like protocols for agent-agent interaction, like We broadly still haven't figured out the best way to use these and like what life, optimally looks like, via leveraging, AI. And so, yeah, I think as time goes on, of course, we'll formalize like learnings and we'll look back and we'll be like, why were we doing this, or why were we doing this like AI, like random, AI coworker startup or whatever? Like, it'll seem so obvious in retrospect, but maybe we'll remember like just kind of how difficult it was like for a while to actually figure out like how to use these things well. I mean, think about like how foundational tool calling is to the agentic experience today. This was not even something that was in the original release of ChatGPT or of like, GPT-3 broadly. And there was no such thing as MCP, right? There was no such thing as like computer use, right? So, broadly the industry is still in an exploration phase, in my opinion.
Yeah. Wow. Before we go into like the browser APIs and basically turning like a website into an API, I wanted to unpin the ramp, and there was like a couple other things that you said about like use cases, not for ramp specifically, but you guys are highly focused on like real workflows that produce economic value. And those economic or those use cases can be quantified, right? You can say, okay, this workflow costs $10, and you can tell the customer it's going to run this many times with this many iterations, $10 to file this receipt, right? And they can determine if that's valuable. What are the big or kind of main use cases that you're seeing for customers that are looking for real work done?
Yeah, there's tons of compliance workflows that are like super valuable. Healthcare automation, healthcare portal automation, financial workflows, bill pay, bill pull, receipt pull. A lot of these transactions that there doesn't broadly exist API support, right? Then we have, large agentic customers that need reliable infrastructure to surround their general purpose agents. So their usage of a browser may not be in a consistent fashion, right? Like they're using the browser for their customers, but they support their customers using the browser in variable ways. I think there are also, some customers that wish to provide the capability to define agentic browser automations for their customers, right? So they're focused on that harness or application layer that sits on top of the infrastructure. Developing infrastructure is not easy, and it's particularly harder in the age of AI because the workloads that AI does are just like, it's not how a human would do it, right? Like a human would maybe scale up, like maybe not linearly, but, sort of like gradually, and then like maybe higher and higher. Whereas like an agent will just be like, shit, 100 browsers, give them to me, and like, that's really tough, like how forces interact change when like the volume of those forces increases, right? So maybe that's fine, if you only have 10 customers, if someone's like, oh, I need 100 real quick. But when we're trying to serve thousands of customers concurrently, right? Then things like, then we need to sit back, with our infra team and say like, okay, well, how do we scale these systems, right? Like, how do we, prevent any single point of failure, right? Like, how do we make them resilient, and how can we make them scale quickly, because our customer, workflows can be, very, very spiky.
Yeah. Without like all the details and nuance, I know someone is still sitting here with like the question in their head, okay, how do I know this thing is not gonna like email my ex-girlfriend to sign up for my new product? So the stakes here are huge, right? For these things working. So like how do like just that kind of abstract thought, like how do you actually, if you can answer like what are just the guardrails around something like that?
Yeah, I mean, my perspective is that security is the root of scalability for agents, right? So if your agent is not secure, right, I'm not going to have it do more things, right? And other people will not use it, right? So you ought to figure out ahead of time, like, what are the types of guardrails that you need? How can this thing like go off the rails? And how can I make sure that it just reliably does what I want it to do? And I think there's a couple things. Like, number one, for like generally low impact workflows, or like maybe, workflow where you're like, can actually like monitor it in real time, there's a very low likelihood chance that it will email your ex-girlfriend. Okay. Very low. Because actually, models are pretty good at instruction following, right? And unless like something is injected into the context during the course of the trajectory to guide it towards that, I mean, again, it's next token prediction. And these things are pretty good at predicting the next token, right? So it feels like if you ask it, to order groceries, that like emailing your ex-girlfriend is like not really in the path of like next token prediction. Now, I think this gets a little bit different. Maybe you're getting at like some weirdness with like, maybe if you have like an OpenClaw or like a Hermes agent, right? And OpenClaw is a very interesting project because I think it exposed two really important types of features that like people just desire in agents, but in like, maybe a bad way, right? So like the first feature is that it has broad access to everything, right? And this is where potential emails to people that you don't want to talk to like comes into play, right? Because this thing is plugged into your email, this thing is plugged into your text messages, it has a browser, like it has access to all of this stuff, your bank account, like I don't know, people are giving anything to their OpenClaw these days, right? Because it has broad access, and by the nature of LLMs, like it will complete problems in novel ways, right? It will string together tool calls in ways that like you didn't anticipate ahead of time, and that makes it extremely powerful, right? Because this is very capable, right? And then the other way that OpenClaw exposed like some AGI magic that people like really like is event-driven execution. So it's no longer that like, oh, my agent only does stuff when I like point the finger at her and I say like, go do this thing. Something external happens in my life. I receive a text message, I receive an email, something like that. And the agent responds and proactively does work for me on my behalf. And those two things together are create a very like powerful agentic experience, because things will get done and you're not even directing it to happen. Things and problems will be solved in ways that you do not even expect that they could be solved, right? I'm pretty sure the creator of OpenClaw like told a story about how he sent his agent a voice note. And because it had access to a browser, it looked up like the OpenAI embeddings and figured out how to download them and then convert the voice note to text and then do the action. So again, like, you know, you don't think that, okay, if I just give my agent like a computer and a browser, then it could possibly, you're not expecting in advance that it could figure out how to transpose a voice note into text and then kind of follow that instruction. The problem with OpenClaw is that the way it achieves this broad access is like completely disregarding security. And that's why you have these instances where like people are posting on Twitter like, oh, my OpenClaw was texting my ex-girlfriend. I saw something like that, right? Or like, oh, like my OpenClaw like deleted my database or like kept deleting my emails or was like doing all these inadvertent things, right? So, you know, going back to the point where like security is the root of scale, this is my opinion for why you did not see OpenClaw basically displace every, you know, agent harness in existence or get broadly, like, do you see like major enterprises saying like, hey, this is our like, you know, Notion for a reason did not implement their Notion agent on top of OpenClaw, right? Or many other companies, you know, they're not thinking like, oh yeah, let me use this thing, you know, despite these qualities, right? You can build those qualities and you can give an agent a wide array of access to stuff, but in a more secure way than like, hey, let me just throw a bunch of credentials on a Mac Mini and like load this thing up on a Mac Mini and then like chat with it through WhatsApp, you know? So as far as guardrails go, like my belief is that what you're trying not to happen should be verifiably impossible, right? So a good example is credential exfiltration, like from a sandbox. So, you know, even to use an agent in a sandbox, you need an LLM API key. So you already have something that's sensitive. And people's like solution is they load it into the environment of the agent. And like that, you consider it gone. You know what I mean? Like it is not that hard, like to exfiltrate an agent, right? You need to steer the conversation towards the probability distribution where the agent sends you the API key somehow, right? It can send it to you in plain text. It could send a post request, right? It could download. Don't even get me started on an agent's NPM installing. Again, you're going to start getting me like stressed, right? You know, any myriad of things could happen where this API key goes from existing on the environment on the sandbox to somewhere it shouldn't be, right? And so a lot of these sandbox vendors are starting to get savvy right now. They have this concept of like credential brokering, right? So you're running an agent in a sandbox. You need it to talk to things like external services that are sensitive. Okay, well, you know, give me a domain, right? Let's say Anthropic or api.anthropic.com. And, you know, load the secret to somewhere secure. When requests come outbound through egress on the sandbox, we will catch that request, we'll terminate it, we'll unwrap it, we'll insert the API key into the header, we'll wrap it back up and send it to the provider. And so this way, you know, you're able to interact with sensitive APIs, but there's nothing to exfil, right? But this still gets more complicated because, you know, you still want to protect access to that sandbox, right? That sandbox is still needs to be some kind of trusted environment because what happens, maybe if you securely call a tool and that tool has sensitive data and now that data is in the context window of the agent, right? And so this is why it's like credential brokering is not enough, right? Like just because I credential broke some secrets, but I still let my agent NPM install something. It can install something malicious that yanks the chat history of the agent. And in the chat history is sensitive stuff that was exposed to the agent's context. So it's very complicated, basically.
Yeah. Wow. Yeah. There's so many, and I feel like this is talking to why we've seen so many hacks and exploits, like not even just like in the crypto space where there's a lot, but even in the like Web 2 AI, like Anthropic and all these different companies.
Yeah, it's crazy. It's an unsafe world out there right now, and it's definitely I think causing anxiety, at least internally at Browserbase. We're definitely thinking about this, and especially it's especially ironic that it's happening during this type of experimentation phase with agents. I won't say their name, but a startup yesterday just disclosed that they had an exploit happen through an escalation of an agent that monitors their infrastructure, right? Like they have like some agent deployed. I guess their agent's doing something to like monitor the health of their infra, like things are going good, and maybe triage or like escalate if things are going wrong. Somehow this attacker was able to like probe, like expose like public surface of their technology, like gain control or interact, or even maybe have interacted with this agent that monitors the infrastructure, and then escalated it permissions and like impacted their customers. And like that's like very scary, you know. And so yeah, I think, you know, we'll continue to go through this tumultuous time for a bit. It will necessitate like, you know, real solutions to this type of security. But I think, you know, ultimately we'll be better off for it because we'll have more secure systems. And finally, when Anthropic gets enough compute, you know, they can drop Mythos and we can all hack each other. So it'll be good.
Nice. Okay, so can you talk a little bit more about, you guys have this product that basically converts the sites into an API or like machine readable for the agents themselves. Can you just talk a little bit about that and like what problem is that aiming to tackle and solve, et cetera?
Yeah. So actually, this is just a skill, right? It's literally just a skill. And if you don't know what a skill is, it's Markdown. You Google it, right? Like it's literally just Markdown. And I think that's what's so beautiful about skills, is it is such a simple primitive, but extremely powerful, because you can have tons of different, essentially like standard operating procedures or different types of guidance for the model. And I mean, a lot, right? Like you could have 50, 100, you know, I don't know, 500 skills, and in very like token efficient way, like simple routing rules in your system prompt around if this type of scenario shows up, right? Like, if someone asks you a data question, right? Invoke the Snowflake skill, right? And then the Snowflake skill can say like, hey, if someone's asking you this type of data question, like, maybe about sales, right? Invoke the CRM skill, right? And if the CRM skill can, you know, you can like skill chain, and you can make like very, you know, codify very complicated workflows in these skills. Additionally, with skills, you can attach code, right? That the model can execute. And so skills is an interesting distribution mechanism of both industry knowledge, right? And like capability. So like you're not only like creating the tool, but you're like, yo, you want to use this tool? Here's some ball knowledge. And here's how to do it, right? And you pair that with like very adept and intelligent agents, and all of a sudden you get tools that are like very powerful and can operate on like very ambiguous problem spaces. And so browser to API is actually nothing new, right? And there's a ton of players that have attempted to like basically make a business around this, right? Where you say like, hey, this website basically has information that I want. I would like to get this information, you know, in like an API contract, right? It's a simple interface for something, for a module that can be rather deep, right? Because you may have to traverse different sites, you may have to log in, right? But in reality, people just want that simple interface. And an open API spec, right? Browser to API. I don't know. We were trying to come up with like a savvy name for it. We landed on that, but it really generates an open API spec, which can be turned into an MCP, that can be turned into a CLI, right? It's basically just like a top level interface that says, hey, here's the URL, and then here are the type of parameters that this thing accepts, and then here's what you can expect to get back. And so browser to API uses our Browse CLI, which under the hood is built on the same browser automation library as Stagehand called Understudy, which basically creates a high level abstraction for interacting with browser through CDP, which is Chrome Developer Protocol, right? Chrome Developer Protocol, very ugly, very verbose, very difficult to work with. Understudy, very nice. Page.click, page.scroll, etc. Like very just like high levels declarative commands. And the Browse CLI exposes that in a CLI functionality. And then there's concept of Browse CDP, which is a functionality I built into the CLI that allows you to create a parallel WebSocket connection, right? So, you know, if I'm using Playwright, right, or if I'm using a browser automation library, I connect to the browser through a WebSocket. So it's continuous, like bi-directional communication. And that's how it's like a remote controller. Like that's how I drive the browser, like through this WebSocket, right? Like, scroll down, click this button, type these things, blah, blah, blah. Chromium browsers accept multiple CDP connections, and pretty well, actually, as long as, you're not like, one CDP connection is doing the majority of the work, and then the other one is maybe listening passively, right? And that's exactly what Browse CDP does, is from your command line, creates the second CDP connection to the browser and passively listens to all the CDP logs that are occurring in the browser. So that's network activity, that's like JavaScript evaluation activity, that's you can see the other things that are attached to the page, right? So it takes all the CDP logs, it periodically takes snapshots of the DOM, so the HTML, and then it periodically takes literal screenshots of the page as well. And so what Browser to API does is it gives a special directive to the agent to instrument browse CDP and output and transpose those CDP logs into a semantically organized and traversable file system. And this is the observability bed that Browser to API is built on. And so you can see exactly what's happening at the network level. You can see exactly how the page looks like. You can see screenshots of the page. You can see which network requests fail and basically how the page operates. And from that, the agent can start to say, I see this request came in after I clicked this button, and this request returns data that may be interesting, right? And then it goes and it discovers those APIs. It identifies that you can call them irrespective of the browser being opened. Sometimes you may need a token, sometimes not. But this is where, Codex or Cloud Code can come in and ascertain that. They have this domain knowledge already baked into their training data. And then what comes out is a clean API spec that says, hey, you're going to Hacker News. Here's the API endpoint that the Hacker News front end uses to populate its posts. And here's how to invoke that API directly. And so for some protected sites, it may not be so simple, right? But imagine, you have maybe a real estate directory, and that directory has 100 or 1,000 pages, and each page has 10 homes on it or 10 properties. If I were to do that through browser automation, and extract all the information about these properties, I have 10 properties, and then I click a button, and then I get the 10, and then I click a button. Okay, I'm clicking 1,000 buttons, right? That's a lot of buttons. Instead, if you found the underlying API, and that API is of course paginated, then I could say for I equals 0, to 1,000, hit this API and shift the page each time you hit it. Mm-hmm. And you can turn, even if you have to run it on the browser because you need some type of special cookie that's only issued on the browser, running that for loop on the API is significantly faster than clicking through each page. Where again, right, you're accumulating risk through each individual action that you take, and you're accumulating costs through each individual action that you take. So yeah, that's Browser to API. Did super well. People definitely resonated with it. Created some controversy in Japan. I guess, this developer in Japan made a CLI for this online grocery store, maybe a few days before I posted that. So yeah, I heard a lot about that from Japanese Twitter. That was kind of cool.
That's nice. And just to be clear, this is something you put together, and this is all your domain knowledge, correct, right?
Yeah. I put together Browser to API. Definitely want to shout out Shrey, my coworker here at Browserbase. He helped put together the video that we posted. But yeah, and like I mentioned, this is not using the underlying APIs of a web page in a browser is not something that I necessarily came up with for the first time in history. But I packaged it up in a skill, which is an amazing distribution mechanism, and provides a really easy interface for people to understand, right? Hey, browser to API. I'm going to go from a browser. I'm going to get an API back. That's all you need to understand. You download it, and then, you use it with your agent. And, I got a ton of comments and quote tweets about people using it successfully and automating stuff. So that was super dope.
That's awesome. Yeah, I feel skills kind of get trivialized a lot, and it's text file, it's what is it worth, right? But for something like this browser API, where this has like a lot of domain knowledge from, yourself who's deep in the trench.
And code. And code.
Yeah, yeah, and code. So I think that even is something too, where like even myself initially, I've seen these like skill marketplaces, and I'm like, where's kind of the value? But over time, and you're kind of confirming here, I'm seeing more of this transfer of knowledge into the skills, and it's very like specific things. So yeah, I think you're pulling on something that probably will have legs, and maybe skills evolve into something even more rigorous, like an agent or something like that.
Yeah, I think so. I mean, again, we're all still exploring. We're all still figuring it out. We also don't know how the hell like we're supposed to interface with these LLMs, right? I think skills are particularly powerful. The intermingling of soft rules and code is interesting. And again, yeah, like packaging domain knowledge, like, hey, here's how to do this thing with the actual tool to complete it, is particularly powerful. And I think, tangentially, it's a great distribution mechanism.
Yeah. Just as we're wrapping up here, this is the last question for you. Based on all the stuff you're looking at, like all the tech and the agents, not necessarily related to Browserbase, or it could be, but what is like the biggest alpha that you've seen? And we're at the end of the video, so less people will will see this, but yeah, where
Mhm.
is like just some concepts or tools or ideas, or where you see the spaces going that you think is going to have a lot of value or growth potential?
Hmm. I think the biggest alpha in AI right now is actually like upskilling yourself and making yourself smarter. I think trying to figure out how to do like how to literally automate your entire life with an agent,
Mm,
and not really actually, thinking about the ways in which you're nurturing your own intelligence, you know, especially considering like how much you can use an agent to cannibalize your own thinking. A lot of people have, talked about how they feel like their like brain is like, going through like atrophy, or I don't even know what like the active like verb word of it is, but they feel brain atrophy, right? Because they're not like, it's like if you go to the gym, right? If you stop going to the gym, you're not getting sore, and therefore your muscles are not growing, and so then you kind of like lose your muscles, right? So like I think it's really easy to like vibe code yourself into oblivion. Like you quite literally can like buy enough tokens to basically code continuously through each waking hour of the day and then go to bed. But I often find that those people that are doing that aren't really getting much done, right? Like they're kind of going in circles. So, actually one of the technical leads here at Browserbase, Walker, great engineer, and we were talking the other day, and he was saying that he read the study where you essentially, when you're doing something, you can either like focus on doing it, or you can spend time like learning and upskilling. And it's like really difficult to be both doing something and upskilling at the same time. And I think that's even more pronounced in the age of AI. So I'd say there's like a lot of alpha in, like reading books, like studying, thinking, writing, along with, of course, figuring out ways that you can augment your AI output, or
yeah.
your output or your productive output with AI. So yeah, like invest in the human. Like let's sort of like reframe a little bit, right? And I released this article on Twitter recently called like, "What if fully autonomous is the wrong goal?"
Mm,
Right? Like everyone is racing to make a fully autonomous like ABC, right? Like I want a fully autonomous product marketer, right? Like I want a fully autonomous like software engineer, etc. And it's like, yes, we want to go into the future, and like we want AIs that can like do stuff. Yes, definitely, right? But like what are we what outcomes are we grounding in, right? And so that was my sort of call to action in the article. Like, look, you're thinking about doing something with agents, cool, right? Or you're thinking about solving, generally you're thinking about solving some problem, cool, right? What are the underlying goals or outcomes that you're actually trying to manipulate through solving this problem, right? Like a fully autonomous agent is but one solution in the set of possible solution in the solution space,
yeah.
right? So maybe instead of grounding yourself in that solution immediately, because that's broadly what the industry is trying to do, or because, I don't know, like it feels cool or like it feels good, right? Like it seems cool. Instead, sit down and define what are the concrete business goals that I actually want to complete, and reclassify AI, and particularly agentic AI, as just but one tool in the possible set of tools that you can use to attack the problem. And then approach the problem from first principles, being agnostic to the solution, right? Like to any one solution. And I think this is most pronounced in areas where people are investing in AI, where people are heavily doing the work. Do you think about software engineering? Is a classic example where so many companies are marketing and like aiming towards this idea of an autonomous software engineer. But like, what key business problems are you actually solving in software engineering? Because the biggest business problems I see in software engineering right now are like constrained software engineering bandwidth, spiky workloads by AI, just intense explosion of cognitive load, and being like kind of unable to like offload that cognitive load. And these have always been problems, right? Or the review process is totally broken, because I can go Codex Goal, make 1,000 PRs right now, and drop those PRs onto my team lead. You think he's gonna be happy? Like, no, he's gonna be pissed, bro. Like that, like making code or like just generating output, it's like not the equivalent of driving like an organizational outcome, right? And so people are like really focused on fully autonomous, like they're gonna achieve fully autonomous slop, right? Where my framing is like, what are key goals, like key outcomes that we want to attain, right? And to what degree do we want to manipulate or drive these outcomes? And what are the tools at our disposal? And within that, like, how can we think about work completion as not, oh, there's all this work and there's all these AIs, and like, how do we get all these AIs to do this work? And rather, there are people, there are AIs, and there are this work, and how do all of those things interact in order to complete that?
Yeah. Wow, man. Yeah, that's really well said. I think I resonate very heavily with all that, and kind of to double down on the like just coding to code. And it's almost addictive, and you can kind of
It's a video game.
Yeah, yeah. You can go into like psychosis almost, right? Just coding and coding and coding, and you work, and then you kind of just flip into these new project, and maybe after a month, okay, what have I shipped, right? And it's like this pseudo accomplishment or like doing.
It's like performative productivity, and like look, there's nothing wrong with it if you like to code, but like recognize what you're doing, right? Like recognize that like you're having fun, and like if you're good with that, like there is coding to have fun, in my opinion. But like, I don't know. I don't show up, Paul, I hope you're not listening at this point. I don't show up to Browserbase to code for fun, right? I'm coding for money, and I'm like coding so I can make money and Browserbase can make money, right? And so it's really important for us to like stay grounded in like what we're actually trying to do, and the outcomes that we're actually trying to drive, right? Like, and I mentioned this in the article too, like developing, using agents or more broadly, developing software is a business activity, right? And business activities need to impact customers, business productivity, or costs. And like, if you ain't doing that, then you ain't doing it, So that's that. I'll get off my soapbox.
Eric, man, this has been really good. Yeah, I appreciate you coming on, and thanks for sharing about all this stuff, and hope to have you on soon.
Yeah, thank you for having me.
Yeah, see you.